This session is called A Tale of Three Images, and they're all the same scan, all the same photo, but there's very important differences among them, and the goal is to better understand resolution and file format and how that applies to your blurb photos. So if I mouse over each one of the image, you see that a box appears, and the box indicates item type, date taken, rating, dimensions, and size. And if I mouse over here, even though the picture looks the same, notice that the item type, date taken, dimensions, size, that might be a little different. So I'm going to mouse over to the next one, and again, same information, but notice that the actual numbers that are plugged in are slightly different. Notice, for example, here the dimensions are 623 by 775, and if I mouse over here, it's 1868 by 2325. So there's something going on here. Even though these pictures look the same, for some reason there's different information coming up about each one of the photos, and that's what we're going to look at in this session. If I single click on an image, I get the same information that was in the box, except it's spread out across this bar on the bottom. So I'm clicking on this photo, and the size of the photo is 1.13 megabytes. If I click on this one, the size is 12.4 megabytes. If I click on this one, it's not even a megabyte. It's 128K, which is a very small fraction of a megabyte. Notice the dimensions are 623 by 775. That's the number of pixels that are in the photo. We're going to look at pixels in a minute, but the dimensions, what this means is that the picture is 623 pixels across and 775 pixels high. Now, if I click on this photo, notice how the dimensions, the pixels are 1,868 pixels across and 2,325 pixels high. If I click on this one, it's the same number. It doesn't change at all. I'm going to click here and notice the number of pixels. I'm going to click here and notice the number of pixels does not change at all. So they have something in common, but notice that the size, and this is not print size, this is not what size your picture would be, but by size, Windows is telling us how much file space on your hard drive the picture will take up. So here it's 1.13 megabytes versus 12 megabytes. Big difference. And then this one is 128K. So this first picture is a JPEG. The middle picture is a TIFF. And the last picture is a JPEG also, but it's a low resolution JPEG. So what I'm going to do is I'm going to, with this image clicked on, I'm going to click on preview, and we see our photo. And notice as I go from the JPEG to the TIFF to the first JPEG, the pictures really don't look any different. Even though there's a difference in file size, even though there's a difference in resolution, as I go from one picture to the other, I'm clicking from one picture to the other, and you can see the file name change up here. Notice this is the JPEG, this is the TIFF, and then this is the very low resolution JPEG. The picture hardly changes at all. And that's what can be confusing about this. And the reason that the picture does not change at all is that the monitor, the requirements for display of this picture on the monitor is only 72 pixels per inch. So if I go up, and we're going to look at the pixels right now. If we look at, well, let me go to this picture. If I magnify this image and zoom in, we see that the eye is made up of a series of squares, and the squares have different brightnesses. You see that this is a black and white picture, so there are some squares, pixels, that are black, some that are gray, and some that are very light in color. I don't see any white pixels here. Here are some that approach white. So we can see that there is a definite pattern of squares in this photo. But when we zoom back, we see that it's just a regular picture. It looks pretty good. So I'm going to go to the 12 megabyte TIFF file, and I'm going to zoom in, and notice how much I can magnify this picture, and it still looks like an eye. If I magnify all the way, we can see the squares, but notice how well the picture stays together. This is the quality of a high resolution image. So this is a TIFF file, a 12 megabyte TIFF file that had the high resolution, that had the 1868 pixels by 2325 pixels. So I'm going to go to our very first picture, and this is also a JPEG, and it's the same resolution of the TIFF that we just saw. So I'm going to go right into the eye here, and notice how well it still looks like an eye, how well preserved the eye is at the high resolution. And this is all compared to our low resolution image, which starts to fall apart right away, to where we can, even at this magnification, we can already see the squares. This is an indication of poor quality. So here we see the squares. And again, I want to emphasize, here's the one where the squares showed up right away. 128K. This would email very quickly. This would upload to the internet very quickly. That's the advantage of having such a low resolution image, but it would not print well at all in your blurb book. Here we have a very high resolution image. It's a TIFF file, and a blurb does not accept TIFF files, so you can't use that. So what's the answer to getting good quality? Save your TIFF file, your high resolution TIFF file, as a JPEG, and look at how the file size gets smaller. And the reason that it's smaller is because the JPEG file format is able to compress the 12 megabytes into 1 megabyte and still keep the high quality. The important thing is to know what you're looking at. You don't need any fancy software. All you need is Windows, and all you need to do is know what to look at. I hope this helps a little bit in understanding resolution. The idea is all these pictures can look the same on the monitor, but that does not mean they're going to print equally well.